Okay, this is going to be a video about graphing a quadratic and its inverse. And for this video, we are going to use our graphing calculator. So go ahead and turn on your calculator, press graph, and just make sure that your grid looks like this. And if it doesn't, you can just press zoom and then 6. And you'll see you have that nice standard window. So go ahead and in y equals, press x squared. And this is just a reminder that you can always pause the video if I'm going too fast for you and watch it again, or pause it so that you can catch up. Now after you type in x squared, you're going to press graph and you'll see there's our parent function. So if I want to see a table so I can get some nice points on my grid, I'm just going to press second graph. Oops, hold up, I'm set up a little differently. There it goes. Second graph, and there are my nice points. So I'm going to graph the points for f of x. I'm going to graph -3, 9. I'm going to graph -2, 4, 0, 0. Whoops, I forgot one. I'm going to do -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So I'm going to go ahead and graph those points now. Now, just as an FYI, if you don't have your calculator with you, you can just plug the numbers in. I mean, put -3 here. What's -3 times itself? 9. What's -2 squared? 4, and so on. So you really don't need your calculator, but it's nice to have. And there's my parabola. It says, on the same grid, graph a relation that represents the inverse of f. Let me get a colored pencil. All right, I got a nice red pencil here, and I'm going to make a table for the inverse. And this is what we just did on our test, so it's not such a big deal. So we're going to go 9, -3. We're going to go 4, -2, 1, -1, 0, 0, 1, 1, 2, oops, 4, 2, and 9, 3. And I'm going to go ahead and I'm going to graph those points. So I've got 9, -3, 4, and again, I didn't need my calculator for that either. And there's, oops, I missed a little bit. Kind of racist. So there's the inverse. Check. How are the graphs related? Well, I don't just want to say that they're inverses. I want to say that graphically they are reflected over the line y equals x. Right, and the way I know that is if I were to graph the line y equals x, grab a ruler, if I were to graph that line on my grid, and you should do this too maybe, that looks pretty good. There's the line y equals x. So if you tilt your head a little bit like this, you can see like these two graphs, they match up over the line. Like if I folded the paper in half, they would match up perfectly. So state the domain and the range of f. So f is our parabola, and so the domain we're going to say is all real numbers. And another way to say all real numbers is this fancy symbol. It's like the paragraph symbol, but it's an R. And then the range, oh, we say this is all real numbers because like the whole graph stretches from left to right. Like every single x value is here. Even if I can't see it, all the one, even 10 squared is 100. It's somewhere up here. I just can't see it. But the range, I don't have every y value on this parabola. I only have positive numbers. Like there's no -1, -2. There's nothing down here. So I want to say everything higher than and including 0. So I'm going to say y is greater than or equal to 0. Okay, so now number 5 says determine the domain and the range of the inverse. When I look at my red function, I see that its domain is only positive numbers. So its domain is x is greater than or equal to 0. And then the range is going to be all real numbers because this graph goes from top to bottom. Is the inverse a function? Why or why not? No. It doesn't pass the vertical, I forgot the A, line test. And just as a reminder, the vertical line test, like if I went right here at 4 and I drew a vertical line like this, at 4 I have 2 outputs, and I can't have 2 outputs if it's a function. Okay. The next page says, number 7, if we restrict the domain of f of x equals x squared to greater than or equal to 0, will its inverse be a function? So let's go back and look at our graph. Here is x squared, and if I only have greater than or equal to 0, that's only looking at this half. So if I keep this half, it matches up. Do you have a highlighter? No, but I have a crayon. I'll take the crayon. So if I use just this half of the graph, it will match up. So like if you kind of turn it and you look at the inverse, it'll match up with just this part of the inverse. So now, I probably should have done that in a different color. I'll make it green. So just this green section, yes, just the green section is a function. If I were to erase the bottom, I would be good. So, will its inverse be a function? Yes. And I might make a little note to myself, draw a little picture, is a function. Okay. It says graph x squared, f of x equals x squared with the restricted domain on the coordinate grid. So I'm just going to go ahead and be like, recopy that half. So 0 squared, 1 squared, 2 squared is 4, 3 squared is 9. Okay, whoops, I missed a little bit, but that's okay. Check. Write the equation using what you know about inverse operations. So what's the inverse of squaring? That's right, it's square root. On the same grid, graph the function that represents the inverse of f. Now, just I want to point something out. If you were to go onto your calculator and you went y equals and you typed in square root of x, to get the square root, I go to second x squared, and you press graph, there it is. It's just that one piece. So now if I invert just these 4 points, I've got 0, 0, then I've got 1, 1, and then I've got 4, 2, and then I've got 9, 3. Here we go. State the domain and the range of the inverse. So when I look at my red graph here, it has a domain of only positive numbers because I don't have anything over here where the numbers are negative. The first x value I'm using is 0, and then I'm using everything after that. So x is greater than or equal to 0 is the domain. And then the range, you can see I don't have anything down here. Like if I look at these negative y values, there is nothing down here. So the range is going to be y is greater than or equal to 0. Number 12 says, on which intervals is f inverse increasing or decreasing? Well, if we trace this red graph from left to right, we can see that it was only increasing. So we can say it's increasing when x is greater than or equal to 0, and it's decreasing never. All right, page 3. It says graph the function x squared plus 3 on the coordinate grid. So I'm going to grab my calculator, and I'm going to go y equals, clear that out. I'm going to go x, and then squared. And just a reminder, again, you can always pause the video if you need to, or back it up. Plus 3. And I'm going to hit graph. And I can kind of see on my calculator, it looks like it's starting up there at 3, but I want to get a good table. So I'm going to go, and yep, sure enough, 0, 3, and I can kind of see how it's symmetrical there, like 4, 4, 7, 7. So that's the part, I'm going to make a little note here. The function is going to be x, y. And I'm going to start there at -2, 7, -1, 4, 0, 3, 1, 4, 2, 7. So let's see, -1, 7, -2, 7, -1, 4, 0, 3, and there's our graph. Okay, check. On the same grid, graph the relation. Notice it doesn't say function, the relation. So I'm going to go my inverse relation. I'm just going to switch it around. So inverse x, y, 7, -2, 4, 3, 0. And I'm going to graph that. And I'll do that in red also, since red seems to be the color for inverses today. So I've got 7, 2. Oh, whoops. Well, that was that one. So 7, -2 is down here. And then I got 4, -1, 3, 0, 4, 1, and then I don't know why I always miss one. Oh well, not a big deal. Make the point bigger. All right, so there's our inverse relation. Number 15 says, what restrictions can be placed on the original function to ensure that its inverse is also a function? Well, just like before, I have this problem where this is not a function. It doesn't pass the vertical line test. But if I only had the top half, this part, it would be a function. So think, which side did this come from? Yeah, it came from the right side. So I only want to keep this portion. So look at what I just colored in purple over here on the original function. This is going to be only x values that are greater than or equal to 0. All right. Now here's where I don't really love how this is written, because it says determine the domain and the range of f inverse. And the way this is written, it kind of implies function, because it's using that function notation. So right now we're going to scratch out the bottom half. We're not going to use it. Now we're going to find the domain and the range of this inverse function. Because now I can label this as the inverse function because it's actually a function. So its domain, so let's think, what kind of x values does this graph have? This graph has x values starting at 3 and everything after 3. So the domain is going to be x is greater than or equal to 3. Now the range, when I look at y values for this graph, the y value it has is 0, and it's 0 and everything higher. So I'm going to say the range is going to be y is greater than or equal to 0. Increasing and decreasing, number 17. When I trace the graph from left to right, I notice it's only going up. So it's increasing on its whole domain, starting at 3, and decreasing is never. The last question on this page says, what is the left endpoint of the graph of f inverse? When I look over here, I can see I've got an endpoint at 3, 0. That's kind of like the starting point. If you want to make a little note, endpoint is really another way to say starting point. Okay, we're almost done. Page 4. So what I would like you to do at this point is pause the video. See if you can type in number 19 into your calculator and graph number 19 on your own. Obviously, if you can't, you can unpause the video and I'll walk you through it. Okay, if you need help, here we go. I'm going to go to y equals, I'm going to clear out my function. Then I'm going to say parentheses x plus 3, close parentheses, squared. And now I'm going to press graph. And I can see that my graph kind of switched over here to the left 3. So when I go to my table to get some points, I want to make sure that negative 3, because it went left 3, is kind of in the middle. So I'm going to scroll up just a little bit. And there's my table that I'm going to use. Negative 5, 4, negative 4, 1, negative 3, 0. All right. So hopefully you were able to get this on your own, and if not, hopefully you are good now having watched me walk you through it. Check. Okay, graph the relation. So again, even though we know at this point we're going to have some vertical line test problems, we're going to do the inverse relation. So the inverse relation, I'm just going to swap my x and y values. So now I'm going to have 4, -5, 1, -4, 0, -3, 1, -2, and 4, -1. And I'll graph them in red because that seems to be the color we're graphing inverses. 4, -5, and again, just like we anticipated, we've got a vertical line test problem. This is not a function. Wah, wah. So what restrictions can be placed on the original function to ensure that its inverse is also a function? So again, I want to cut this graph. So I only want this left side, or sorry, this right side. I don't know my right from my left. I only want this side. I'll color it in purple. If I only have that right side, it's only going to give me, these crayons are awesome, by the way. I don't know who invented twistable crayons, but I wish I was them. That would only give me this green piece. So if I only had the purple part of the parabola, I would only have the green piece of the inverse. So let's look. What restriction can be placed on the original function to ensure its inverse is also a function? I only want the right side of the parabola. The vertex of the parabola is here at -3. So I'm going to say I want the original parabola to only have x values greater than or equal to -3. So now it says state the domain and the range. And again, because there's this inverse function, I'm now going to scratch off the bottom. I don't want it. If I only look at this green and red part, not the part I've scratched off, the domain, well, I've got the first x value here is 0, and it goes all the way to the right. So we're going to say x is greater than or equal to 0. The range is going to start down here at -3 and be everything higher. So it's going to be, that does not look like a y. Y is greater than or equal to -3. On what intervals is our inverse function increasing? Once again, this inverse function is always increasing. And since it starts at x value of 0, remember increasing and decreasing, we always use x. It's going to be x is greater than or equal to 0. And this graph never decreases, none. Again, we always trace a graph from left to right. So like when I'm looking at this, I'm like shh, going up. And the last question in the assignment asks us, what is the left endpoint of the inverse function? So here's our endpoint. Remember, the endpoint is just another way of saying what's the starting point. I don't know why they call it an endpoint. They just call it a starting point. If I was in charge, I would call it the starting point. Is 0, -3.